Introduction to classifying data. Just as animals can be classified into phylum and then further into species, data collected in a statistical study can be classified into different categories. The different categories group data based on the type of statistical analysis that can be performed on the data. Therefore, knowing the classification of a set of data is the first step in any statistical process. Data can be classified into qualitative data and quantitative data. Qualitative data is also known as categorical data. It consists of labels or description of traits, typically non-numeric but not a requirement. For example, eye color, gender, religious preference, yes or no, hometown, favorite food. The answer to those are all letters or descriptions. The ID number, on the other hand, is a number, but because when you subtract two ID number, it doesn't make sense. So it's non-numeric, it's a label or description. And we use C to represent quantitative data, the categorical. On the other hand, quantitative data, quantity, right? It consists of counts or measurements. So you have to count it or measure it. It's numerical. For example, your height, weight, pulse rate, age, body temperature, credit hours, test scores, average rainfall, they're all numerical. And they are quantitative data. Let's take a look at some example. Classify the following data as either categorical or quantitative. Number 1, the number of homes a bank repossessed in 4 randomly selected months. The number of homes, we can count it. So it's quantitative. 500 people are asked the frequency with which they eat chocolate. Never, seldom, occasionally, or frequently. Now, because the answer is chose between never, seldom, occasionally, or frequently, this data is categorical. Number 3, a McDonald's quality control inspector counts the number of fries involved in individual serving. Because you can count the number of fries, it's quantitative. The license plate of a car is categorical because it's a label. Quantitative variables can be further classified into discrete variable and continuous variable. Discrete variable can be assigned values such as 0, 1, 2, 3, and you usually count them, so they're countable. Or they are the number of something. For example, the number of children, number of credit cards, number of calls received by switchboard, number of students. Continuous variables can assume an infinite number of values between any two specific values. You can obtain by measuring. Often include fractions and decimals. For example, the temperature, the height, and the weight, they're all measured and they can contain decimals. So they are continuous variable. Let's take a look at some example to determine continuous variable or discrete variable. The number on the uniform of a football player. So think about the number on the uniform. They are either, you can think of it as 11, number 2. You cannot have a decimal like 1.1. So it's discrete. The temperature in Celsius in Paris, France. The temperature you can have 22.5 degrees Celsius. Okay, you can have a decimal. So it's a continuous variable. The total weight of sugar imported by the United States each day. Again, when you're weighing sugar, it can be 1,000.5 pound or kilogram. Because it can have decimal, it's a continuous variable. The price of 50 randomly selected new car. Now think about a car, and it can be, let's say, 20,000, 89, 20,000, $895.99. So it can have decimal. So in this case, it's continuous.